Hello everyone, welcome to this new video dedicated to FreeCAD. Today, we're going to tackle a big topic, construction tree. Understanding it better is essential to feel more comfortable with your modeling. I realize that many people struggle because they go straight to their models and are obsessed with them, without paying attention to what's happening behind the scenes, which is the construction tree. So today, I'll show you different constructions. This modeling shows a small artistic flower and also a simple eraser that I presented in a previous video that I made using many different methods. So, the goal of this video is to encourage you to test before starting your construction, because in fact, we are all obsessed with the result. In reality, to achieve it, you need to understand and learn the language of CAD, which is the construction tree. So every time you have your model in mind, you only think about that. But this model is the result of this construction tree, which, by the way, is called a tree, but it's more like a root. A root often, and at the start of your project, you have a sketch, and you don't yet know what constraints or dependencies you'll need. So, what I'm suggesting is to start by testing. You have your product, your project. It could be a mechanical part, it could be an object, it could be 3D print, whatever you want. Before jumping straight into your final modeling, you need to set up a strategy with all small tests to figure out how you'll model it in the end. Because if you jump straight into the final model, you'll hit a wall every time. For example, think about this simple eraser, which is a thick rectangular parallelepiped, 50 mm long, 18 mm wide, and 8 to 9 mm high. There are many ways to model it. You can do it by exclusively using the tools from the CAD Part Design workbench. Draw a line, extrude the line to create a face, and extrude face to create the volume. The more classic way is to use the Part Design workbench. You create a sketch on a plane. Then here are used the additive loft function. So you create a second sketch that is offset, and you create your volume between the two sketches. It's one way to do it. A more classic way is to create the profile and extrude it. Or you can create the face on an inclined plane and extrude it. You can even do it with the revolve tool. If your radius is very, very, very large, which would essentially make it a straight line, and it would come back to the same thing. It could make sense in some manufacturing cases. You can also do it in a completely Boolean way. Create a first volume of material, then remove other volumes of all material. You can also do it using the draft workbench with two rectangles and build edges between them now different points. Another method is to convert your volume into a mesh, and then you can recreate a solid from that mesh. you can make a simple copy, another solid. Refine your solid by removing faces, which can make sense. In certain situations, you can also do it using a sub-shape binder, which can be converted into a volume. Finally, you can create a macro that will also generate the same part. So there are many ways to model this part, and each can make sense in certain cases. So for me, there's no good or bad method. What's important to remember is that there are many ways to do it. So if you want, you can find the document and the files I used in this video in the link in the description below. So, coming back to this model, here's the construction tree. I used different strategies, and now we'll quickly see how we could approach this construction. First, there are different parts, and there are also different tactics for the cowl. Main part, which is the watch case. So we can think of modeling a quarter and then using symmetry to get the rest of the parts. What I want to tell you is that before making a super precise model, do some quick tests. For example, if we want to do a quick test, we can sketch the profile. And then we can test it. Here, we've made our quarter. And we can use symmetry to model the rest. This is practical because we can model one part and then replicate it. This is something you should test. Now, we can test and see if it works. Then for the crown. We can extrude the face. Now we'll hide the horror. But there's a radius, just for the principle. To get an idea. Now we have a quarter of the part. And we can try to use this tool to replicate these functions. What's important here is to take the parts and mirror them. For example, here we have one part, and now we need to test. If we want to mirror the two quarters, we'll need to fuse them. So now we have one part. We didn't spend time making precise sketches. We just did the main modeling. Test the strategy. This is what I want to explain in this video before diving into the details of your part. Do some quick tests. If you want to add in features to this part, you need it to be a single solid. So we fuse it and move to the part design workbench. What you need to understand about FreeCAD is that we have all these workbenches, and they're just groupings of similar functions. But from a software perspective, they're all independent functions. So you can pick functions from any workbench that you need. Now, on your work, you can create chamfers and other features in just a few minutes. We've tested the principle. Now, if we want to add it, the crown passage, we can do it quickly. This is just a test, but you can see how fast it is. We won't do it exactly like this because we need to give it the right curvature. But before diving into details, we just test the method. The construction tree isn't the most exciting part, but it's crucial to understand it. There's nothing complicated here. It's just a sequence of logical operations. We created a sketch, mirrored it, fused the mirrored parts, and then added features like chamfers and the crown passage. These things don't come out of nowhere. You need to test them before integrating them into your project. Otherwise, you might run into issues. So my advice is to do small tests to validate your ideas. This will also accelerate your learning of the software. If you spend too much time on precise sketches, it will slow down your overall learning. By doing quick tests, you can learn different principles and test tools without constraints. So be curious. Explore the different workbenches and test functions. On simple tests, this is the best way to master the software. There's no simple answer. And I often see people asking questions on Reddit The best way is to do small tests to understand what they want to do. So be curious. Explore the workbenches and test functions on simple tests. This is the best way to learn the software. If you found this interesting, let me know your feedback. You can find all the files I used in this video in the link below. I hope you enjoyed it, and see you next time.